Welcome to Ask and Learn.
For part A, we are going to equate the energy at point A to energy at point B. And energy at point A is entirely gravitational potential, so that's mg times r being the radius of the circle, and that is the height from which, or that is the distance through which the object drops, right? And that is equal to energy at point B, which is entirely kinetic because it's at ground level. So that's 1/2 m velocity at b squared. And so velocity at b is square root of, remembering that m's cancel out, is square root of 2g times r. And so that's 2 times 9.8 meters per second, meters per second squared, times r, which is 2 meters. Therefore, velocity at b is 6.26 meters per second. Okay, part B, we want to find out the thermal energy. And for this, we remember ETH is thermal energy. We remember that that's just a force times a distance, right? Force being a vector, and same goes for distance. There will be a negative here implicitly, but then force, the vector force, will be a cosine 180, so that gives us -1, and so negatives cancels, and so we're left with force times distance, okay? And force, remember, is mu sub k, force of kinetic friction, times normal force n. That is multiplied by distance d. Normal force is just the force of gravity, so weight, so that's mu k times mg times d. Therefore, we have mu k, which is 0.25, times m, which is 1 kilogram, g, which is 9.8 meters per second squared, and d, which is 3 meters. And so we get thermal energy of 7.35 joules. All right. Part C, we're equating here the energy at B to the energy at C. So at B, we have just a kinetic energy, 1/2 m velocity of b squared, is equal to, and that is equal to, obviously, the kinetic energy at C, so 1/2 m times velocity at c squared, Vc is what we want, plus the thermal energy that we just calculated. Therefore, Vc, and so we can multiply both sides by 2 over m to get Vc equals square root of Vb squared minus 2 times E thermal over m. And so that's Vb squared is 6.26, as we just calculated, minus 2 times E thermal is 7.35, as we just calculated, over mass, which is 1 kilograms. And thus we have a velocity at c of 4.95 meters per second. All right, and finally, we want to figure out what the spring constant k is as all the kinetic energy at C is converted to elastic potential energy. So this will be, so that's d. So this will be 1/2 m Vc squared, will be equal to elastic potential energy, which is 1/2 kx squared. Okay, x being the compression, the length with length that it's been compressed. So 1/2s cancel, and so you can see that k is just m times Vc squared over x squared. And so that's 1 kilograms times 4.95 meters per second, quantity squared, over 0.2 meters is the stretching length. And thus we have about 613 newtons per meter as the spring constant. And that's it.